Everybody say, hi, Mom. Hi, Mom. There we go. This is now officially being recorded, and this, at the end of the period, will be placed on the internet tonight. So I think today's a pretty easy lesson. I think you'll understand it. And by the way, we're going to do almost the same lesson tomorrow, just to get some terminology down pat. But if you have any difficulties with your homework tonight, if you want, you can go on my website, which I'm going to show you in just a minute. And then you can, the lesson sheet is already on there, and the video will be added to the page. And all you need to do is click on video on today's lesson page, and you will see. Now, as far as my sheet goes, let's see if I am capable of pulling it up on this one. I know I am on my other laptop. This is my laptop. This is the school's laptop. Why is this asking me for this? I don't want eSchool data login. I want, ready? Here's my website name. It's really, really hard to remember. Okay? Mr. Lindquist Math. Can we all say that? Mr. Lindquist Math.com. Now let's hope it comes up. Ah, bingo, it comes up. Excellent. That's Bauer.
Oh, yeah.
You remember Bauer? Absolutely. And there's Ziva. Okay? So here's my math homepage, and this is the homepage. If you come onto it, this will be on there every night. Now, this is algebra. So which one do you think you go to? Very nice. Then you see you drop down to function 1 intro. Then here's calendar. Oh, it must be, yeah, it's already up. So here is a calendar of all the things we're going to do. So for instance, yesterday was class introductions. Today is lesson 1, function intro 1, which is the lesson sheet you have. Tomorrow is intro 2, and so on and so forth, okay? That's just an outline in case you need to know where we're going at any point in time. This is today's lesson. And what you'll see here is a few things. First off, do you see a summary of today's notes? So if God forbid you miss class, hey, good morning. Everybody say good morning, Mr. Sohal.
Good morning, guys.
He is my boss, and he is awesome. He's all over the place.
Thank you so much. Thank you for this. And you have one of the best teachers in our district, so you have nothing to worry about. But you look so studious. You guys are serious, right?
Yeah, they haven't loosened up yet.
She's like, I can't wait to burst open.
Well, she's my star shortstop from last year.
Oh, okay.
Very, very, very great kid and great athlete. I didn't show you this, though. You want to see?
You know, one thing I must point out, I've been walking around schools, the eyeglasses.
Okay.
Everybody has some fancy eyeglasses. If you look around, like, those people are wearing eyeglasses. Those are cool. I like
Style
those.
points.
Yeah.
Style points.
And I think you and I had discussion. I wear contacts.
Right.
And I can't wait to, get the surgery done that Mr. Lindquist had done to correct his vision.
Yep.
And but I'm thinking now maybe I should get one of those fancy eyeglasses. So how's everything?
Good.
Did Mr. Lindquist share the good news for you?
I'm wondering what that is myself.
You won't have a full week of school until October.
Oh.
You
So
guys knew about that? Good.
So check this out. I want to show you. I made my own website. I learned how to use Adobe Muse, and I actually scoped the whole thing out. So anyway, here's the lesson sheet. Obviously, if I click on this, it'll bring up the lesson sheet. We're recording the video right now, so that'll be linked onto here from my YouTube channel. And there's a summary of all the notes for today.
Where is the camera?
Yeah, right? So it's pretty cool, and this will have to do with my goal for the year and incorporating technology and everything else.
Absolutely, yeah.
Yeah.
Absolutely.
So
Good. How's everything else? Good?
I'll tell you one awesome thing. Administration did a great job. We all have period 5 off, all the math teachers.
Oh, nice.
So we're going to be meeting this Friday, period 5, kind of make sure we're on the same page and do a lot of collaborating during that
And
period.
if you think that, there is something that I need to make on the spot decision, invite me and I'll come down.
No problem.
All right, I'm
Excellent. Sure.
always there. All right, and we will, discuss the format of the department meeting also. I want to change it, not
Okay.
the traditional type. I want to meet with select groups.
Okay.
So, that way it's more intense and specific.
Right.
And
Productive.
productive as well.
Good.
So, have a great year, guys.
Thank you.
Come on, a little bit.
A little pep, a little enthusiasm.
I know it's hot outside, but you have more girls than boys.
Yeah, this is the nature of junior high.
Wow.
Yep.
What's going on? Look at that, 5'5".
We're outnumbered.
You're outnumbered, yeah, that's true.
It's like me as a teacher. I think there's 4 or 5 males in the building.
Oh, okay.
Yeah, there's not many.
I was talking to Chris Shaw, Jeff Peterson
Okay.
at River. Every grade there's a male. I said this is the only building that
Where that
grades 3,
exists.
grades 4, grade 5, elementary school has a male teacher.
Nice. Very nice. My niece is over in that building now. She
Oh, yeah?
started kindergarten. Yeah.
Have a great year, guys.
Take care. See you later.
Thank you.
All right. So what we're saying is this. Here's the website. It's very, very important that you understand about this, because if you don't understand today's lesson, where it says here YouTube video, I will put a link right here in a couple of minutes, and you just click on it, and the video will show up. If you click here, the lesson sheet will show up. I'll show you that real quick. So if God forbid you happen to be absent during the day, I don't know why the sheet didn't come up. Oh, here it comes. Okay, good. If God forbid you happen to be absent during the day or you lose your sheet, you can go home, go to the website, pop up the sheet, and you can print it. So that way you can get your homework done. Next, a summary of the notes is available here, and this will be on there every single day. And the video will be there every day. And sometimes we don't get to go over homework as much as I would want to, because we do work very hard in here. And what I will do is, before school or at extra help, I'll record some work on how to do specific homework questions. And if you want to watch the video on them because they gave you a hard time, I will put a link right here to a video on how to do that homework. Okay? Remember how yesterday I said I hate hypocrites? Right? And I told you I work hard? I work very, very hard. So this is one of the things that we do to make sure that you are able to do the things that you're able to do, or that I want you to be able to do. All right. Now, listen, there are some certain things in life that just are how they are. Now, that guy that just came in the room, he's a great guy. And he really is a super, super, super boss. But there's certain things that our bosses want to make sure that they're able to do. And they want you to be able to say what you're learning on any particular day. So that's one of the purposes of this box. Okay? It gives us focus. It lets us know what it is we're in the room, what the purpose of being in the classroom is. But it also lets, if anybody ever says to you, what are you supposed to learn today? Well, today I learned that a function uses input and output. I learned how to identify domain, range, how to represent a function pictorially by rule and table, and so on and so forth. So this summarizes everything you're going to do on a particular day. Okay? Are we all good? All right, so now let's get into a little bit more fun. Up until now, everything has just been nuts and bolts, kind of how we run things, sort of way of doing things. All right, come on, give me the green light. Beautiful. Oh, I got to hit the little doohickey here. Color red. Come on. You know what I have found about these styluses, or styli, I guess, is more to the point? They're a lot like 8th graders. They are. If you smack them around a little, they'll do exactly what you tell them to do. Let's see if it works now. Ready? Come on. Big green. Let's go green. Come on, green. You know, the video looks really, really bad if this doesn't work. Okay, here we go. Oh, here we go. We have potential. We're catching on now. There we go. Yay! All right, ready to rock. Okay. A certain function. Now, what's a function? A function changes things. It transforms things. It gives you an input, which is what you start with, and it makes it into a output. So input is everything that you give into the function. Output is everything that it spits out to you from the function. Okay? It takes the numbers from -2 to 4. Now, this is what we call a table. Over here on the things you're going to learn today, it says how to represent a function pictorially by rule and in a table. This is how we do it in a table. It takes the inputs one at a time, and then I'm going to multiply each function by 2, and then add 1, and you create a corresponding output. So, I take the number -2. I multiply it by 2. What is -2 times 2? Come on, let's go. Go ahead. Nice. Then I add 1. What's -4 plus 1? Everybody, come on. Sweet. You should be very good at your positive and negative numbers. I'm not going to tell you how to do these, but if you have, I'm going to give you a few every night on homework, and then when you come into class, I'm going to give you the answers to them. If you're getting any wrong, see me privately, and we'll catch it up. But I don't really have class time to do that. If you have issues, we can cover it in extra help. All right, now let's take -1. It says again, multiply each by 2. So what's -1 times 2? Everybody? Add 1. Sweet. Oh, my favorite. I love 0. 0 is so cool because you have no work to do with 0. I mean, does it get any better than that? It's like nothing to do. What's 2 times 0?
0.
Plus 1.
1.
Hey, you starting to see a pattern here? Right? We're going up 2 every time. Tables are really, really good at showing patterns. Okay, what's 1 times 2? 2 plus 1 is?
3.
Now, if we follow our pattern and we're going up by 2's, what should the next one be?
5.
Now, let's see. What's 2 times 2?
4.
4 plus 1?
5.
Sweet. All right, what's 2 times 3?
6.
Plus 1?
7.
Notice I went up by 2's again. And 4 times 2 is 8 plus 1 is 9. So that is a function. All right? Function takes input. In this case, the input is the left side of the table. And it creates output. Where is the output? Everybody, where's the output? The right side of the table. Now listen, we have some terminology that goes on here. If you don't understand the terminology, you can be brilliant. You're not going to be able to succeed. I look at it this way. I am a very, very intelligent person. I already have a degree in math and a degree in physics. I learned many, many things in my life. If you took me and you dropped me in inner China and you told me to be able to solve some sort of problem and work my way out, I am going to have a very difficult time even solving the most simple of problems. And I'm not going to have a difficult time because I'm not smart. I am smart. I'm going to have a difficult time because I can't communicate. I will not understand what people are saying to me, and they're not going to understand what I'm saying to them. So we have to be able to communicate. To build good communication means to build good vocabulary. So within this idea of function, and again, we're doing the same lesson today and tomorrow, because I want to really build up the vocabulary so that we all understand each other, and it's going to take a little while to learn the words. All these guys on the left side here, all of these inputs, when you put them all together, that's called the domain. Okay? So the domain is the set of all of the inputs. These guys on the output side there, this is called the range. So the range is the set of all the outputs. The domain is the set of all the inputs. And a little bit later in the lesson, there's a place for you to write that down. Okay. Now, the do it serves some purposes. Some days when we do the do it, we want to be able to make sure that we're able to graph things, or we're able to practice what we did days before. And sometimes we set up the lesson. Now, another way to represent a function is to be able to draw this function as a graph. So we just did it as a table. We did it as a table. It was x, y. We want what? -2, -1, 0, 1, 2, 3. And over here we did, what was this? -3, -1, 1, 3, 5, 7. That was our table, right? Kid, take a look. Do we match? Okay.
4 and 9.
Oh, 4 and 9? Okay. So now this is a table, all right? And this is a function represented as a table. It's also possible to take the same exact function and represent it as a graph. So we're not going to change anything. We're just going to represent it as a graph. I'm going to first plot the point -2, -3. Now, you know, I certainly hope, which axis is which. This horizontal axis, what axis is that? X, nice. And this one is the Y, very good. You know, zero's in the middle. You don't have to label all of them. In fact, I don't really care if you label any of them for now. A little bit later, we'll get into what to do. But in case you've forgotten, because it is a really long summer, that's how we set it up and get going, okay? Most of you, I think, will remember that. If I plot the point -2, -3, have you guys ever played the game Battleship?
Yeah.
All right, you remember how you go like A8, and you line up the A and you line up the 8, and they'll go, you missed. And then a little later on, you might say C4, and you go, oh no, you sunk my battleship, right? Well, that's what we're doing here. I'm going to look where the X is -2 and the Y is -3. So you just told me this is my X-axis vertically. So here's -2, and here's where the Y is -3. So that's the point, -2, -3. Agree? This is all review. I don't think I'm teaching you anything. I think I'm reminding you of stuff right now. Let's have you guys find the point -1, -1. Go ahead. Make it. Mark it on your paper. So, here's -1, -1. Do we all agree? Any questions or issues? Speak now or forever hold your peace. All right, try 0, 1. Okay, 0, 1 is right here. Now, doesn't it make sense that if there's a pattern in the table, there ought to be a pattern in the graph? Does that make sense to everybody? Okay, and there is, look, because there's this thing called slope. Do you remember that? Rate of change. And I'm kind of going like up 2 over 1, up 2 over 1. So what do you think I'm going to do again? Up 2 over 1. By the way, it doesn't always work like that, but in this case, because the highest exponent is 1, it does. We'll get into different scenarios during the year. Let's see if this is next. This would be the point 1, 3. Now remember, any point is x, y. X stands for input, y stands for what? Output. So all along, you guys have been doing coordinates your whole life, which means you've actually been doing work with functions. Input, output, x, y, 1, 3, 1, 3. So all we're doing is taking stuff you already know, and as I write this, you should be familiar with it. We're taking stuff you already know, and we're kind of formalizing it a little. We're going a little bit deeper in terms of what we understand. Find the point 2, 5. Okay, here's 2, 5, ready? X is 2, y is 5, and that continues our pattern again, up 2 over 1, up 2 over 1, et cetera, et cetera. And then here's 3, 7, and 4, 9. And we would connect the dots, making a straight line. And this graph looks like a straight line. So we actually call this function, because it looks like a straight line, a linear function. And you notice in the word linear, in the beginning is this word line. And the reason we know this has to be a linear function is the highest exponent is 1. And we'll get into a lot more examples of that later on. Any questions about this? All right, so what we've covered up to this point in time is the following. Domain, range. What is domain?
The input.
Set of all the inputs. What's domain? Come on, a little louder. What's domain? Nice. What's the range? Set of all the outputs. What letter means domain? X. What letter means range? Y. And then we can represent it as a table. We can represent it as a graph. But there are other ways to represent it as well. And we want to be fluent in all of the ways to represent the function. Okay? A third way is to represent it pictorially. What word do you see at the beginning of pictorially? Picture. So we want to be able to draw a picture of it. Okay? I like the picture because it's a great job of showing domain and range. So let's see here. We have in the domain, we had -2, -1, 0, 1, 2, 3, 4. Right? What were the elements of the range? Talk to me. Come on. Look on your paper. Negative what? 3. Next. Next. Next.
3, 5, 7.
Okay, so first off, can you see that this bubble or oval on the right is the range? Right? Because that is the set of all of the what? Come on, what is this the set of out here? Outputs. What do you think we would call this bubble or oval on the right? On the left, I'm sorry. The domain. Very nice. Now, this is a really nice picture of the transformation. -2 becomes -3, -1 becomes -1, 0 becomes 1, 1 becomes 3, 2 becomes 5, 3 becomes 7, and 4 becomes 9. So this is another way to represent a function. Okay? It's all the same stuff. Everything we've done so far is a representation of the function. Okay? Now, another way to do this, I'm going to skip forward a little bit and then we're going to come back to it a little bit later on. Another way to do this is to represent it as a set of ordered pairs. Now, that's how we plotted everything, so it shouldn't surprise you. Another way to represent this function is, I'm going to write the pairs here. -2 pairs with -3. -2 is the input, -3 is the output, and remember, any point is x, y. So I have -2, -3, then I have -1, -1. What do you think is next? Talk to me, guys. What's next? Everybody. 0, 1. What's next? 1, 3. What's next? 2, 5. What's next? 3, 7. And 4, 9. And you'll notice these squiggles here and here. That means it's a set. All right, so I just put a squiggle at the beginning, which means I am now starting a set. Then I go, brrrr. Those are all the things in the set. And then I go, I am now ending the set. Okay? So that's another way to do it. So far we have a table, we have a graph, we have a picture, we have a set of ordered pairs, and there's one last way to do it. And one of my favorite, I read this once and it really lit me up because it's such a beautifully said thing. It says, come, let us reason well together. And I absolutely love that because it's like, come on, let's put all the pretenses aside and let's just think about this. So this is yet a fifth way to represent a function. It's with what we call a function rule. You think about what's happening to the variable. In this case, I took the input. Do you remember what we multiplied that input by? 2. And then what did we do? Added 1. So the output was the input times 2 and then add 1. Now in math we don't write it like that. That's a verbal expression of it. What letter means output, X or Y? Y. Okay? Y equals, now what letter means input? X. So if I want to do X times 2, I should write 2X. Could I write X2? Yes. But is that the standard way to do things? No. Listen, I do not like President Obama at all. Okay? I think the man is ruining the country. However, the minute he walks in the room, he deserves a certain amount of respect because he's president. So if President Obama walks in the room, I'm not going to go, yo, man, sup, dog, happening? No, you don't talk to the President of the United States that way. When you go in a courtroom, do you go, yo, you, sitting on the bench? No, what do you say? That's the judge, by the way. All right, what do you call the judge in a courtroom? Your Honor, very good. You come in and you say, Your Honor, even if you think he's an idiot. You still say, Your Honor. Now, when it comes to math, there are certain ways we say things. And if I want to say a variable times a number, it's traditional to put the number in front. In fact, we call that coefficient. We'll talk a lot more about that during the year. And then I add 1. Add 1. So this is a fifth way to represent a function. To represent a function by rule. So once again, we have a table. We have a graph. We have a picture. We have a set of coordinates. And then we have by rule. So there's 5 different ways to represent a function. In fact, I think if you tell the truth, you've been doing this for years. Is that fair to say? I just don't think you necessarily formalized it as much as we are. So all year long, we're going to come back to this stuff, function, function, function. That man, Mr. Sohol in the room, the first year they gave the Common Core Algebra Regents, he saw the test right before I did. And I said, what'd you think of the test? He goes, it's all functions. The whole test is functions. He says, if the teacher didn't teach functions, these kids are dead. So naturally, we teach a lot of what? Functions. That's where we start, and we're going to weave this like a golden thread through everything that we do all year. Okay, now, let's delete this and continue on. Come on. Very good. All right. Another way this works is a linear function, okay? Linear means a straight line. And when we graphed it, what did it look like? Straight line. And you should remember a little bit from working with the great Mr. Frank last year that talked about this thing called y equals, hey, behave. You remember this thing, y equals mx plus b?
Yeah.
Right, that should be a biggie in your mind. And Mr. Frank loved that. There's 2 things Mr. Frank loves to do. I think he's retired now, I know you know that. I think he's home doing 2 things. I think he's graphing, and I think he's checking. He loves to check. Did you notice how many times he asked you to check last year? I almost never asked you to check. I figure if you didn't learn it with him, you're not going to learn it. Okay? Next, he loves to graph. So I think he spent a lot of time on y equals mx plus b. Now, do you remember what m stands for? Slope. Very good. Do you remember what b stands for? Do you remember? The y-intercept? Okay. Now, we're not going to do much with graphing a line right now, but I think it's worth together. Or remembering, putting it all together, substituting for m and b, the function is this. The last problem, y equals 2x plus 1. We had already said that this was the answer. And notice, doesn't this fit the y equals mx plus b format? So it's not that I'm going to test you on this right now. We cover this in depth later in the year. But I want you to see how what we're doing is stuff you've already covered. I just think instead of looking at it like this, I think we're coming to the side and looking at it like this. Okay? But it's the same exact stuff. Next, a second situation. We have a pictorial representation of a function. It represents the amount of money that Jenny saves in her bank account from her summer job babysitting a neighbor's children here. So, 0 pairs with 10, 1 with 30, 2 with 50, and so on and so forth. What I want you to do is make a table. Okay, now, when you create that table, what letters go at the top? X and Y. What does X mean?
Domain.
Well, if you put them all together, it's the domain. But a specific single X means the input. Y means the output. If I put all the Y's together, I create the range. Very good. So, 0 goes with 10. 1 goes with 30. What's next? 2 with 50. Next? 3 with 70. And last, 4 with 90. Good. So that's taking the same exact function, and we're representing it as a table. You know what it's like? Hello? Hola! How do you say hello in French? Bonjour, right? I thought that might have been goodbye. Okay, bonjour. Shalom! Aloha. It's all the same exact thing. It all means hello. Well, all of these tables mean the same exact function. It's just a different way of saying it, okay? What's the domain, everybody? 0. Keep going. 1, 2, 3, 4. Instead of all the inputs, I just look here. There's my inputs. There they are. I could also look on the left side of the table. Now, what's the range? 10, 30, 50, 70, 90. Excellent. Okay. Now, slope, another way to say slope, because this is linear, is the rate of change. Do you remember that terminology, the rate of change? Okay. What's the rate of change in this problem? Take a look. Anybody think they know it? M?
The outputs are all going up by 20.
Right. So we would say the slope is 20. If you want, you could say 20 over 1. Because the rate of change is 20 or 20 over 1. Okay? Is this ringing a slight bell about slope and y-intercept? Okay? The y-intercept is always paired up with 0. It's always where you begin. It's always paired up with 0. So what number is paired up with 0? 10. So the y-intercept is 10. Okay? Have we done anything difficult?
No.
No. I think all we're doing is like jarring you out of your slumber of summer, your summer slumber, if you will. And we're taking things that you already have a lot of experience with, and we're just kind of formalizing things a little bit as we go along. All right, now, what would a function rule for this be? Now, keep in mind, we already said it's linear, so we want it to be in the form y equals mx plus b. And we did figure out m, and we did figure out b. All right, I'm trying to learn names here. What's your name? Francine. What do we get? That's right, y equals 20x plus 10. Now, I want you to notice something. This rule explains everything that went on in the table. What number paired with 4 in the table or in the picture we just drew? 90. So if I plug in a 4 here, what's 20 times 4? 80 plus 10, 90. So I can explain it with this rule. I can explain it with the table, or I can explain it with the picture or the graph and so on and so forth. How could we reason this rule? Well, we could reason it by saying, look, every time I took an input, to get the output, I had to multiply by 20 and add 10. Or I could say, each time I went up by 1 with the input, I went up by 20 with the output, and I started at 10. Those are ways that we could reason it. Now, as far as graphing it goes, I want you to notice something. Do you notice how there are no negative inputs and no negative outputs. Does everybody see that? Right on the table we just drew, or the picture we just drew? So I don't really need the second, third, and fourth quadrants. 2, 3, 4, I don't need them. Everything's gonna be in the first quadrant. So I'd like you to draw a picture of it, but that's only the first quadrant of your graph right there. I don't need the rest of it. Go ahead, graph. If you think the numbers are too big, change the scale on your graph. If you're feeling a little bit lost, I put a scale up on the board that will work. There are other scales that will work. You don't have to use mine, but mine works very well. Okay, so what's the first coordinate that you have to plot? What's the input-output pair that goes first, the ordered pair? M?
0, 10.
Oh, you did that one first? Oh, you said 0, 10 or 2, 10?
0, 10.
I'm sorry, I thought you said 2, 10. All right, there's 0, 10. I like it. What goes next? Somebody else help me here. Let's go. Hunter?
130.
130. Nice. Next, what do we got? Talk to me. Saxon? 250. Sweet. What do we got next? Oh, hold it. That wasn't 50. This one's 50. I could draw them, connect the dot that way. Okay? I thought we had a couple of more minutes left here. I thought we ended at 04. It is 04. All right. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Ta-ta. Toodaloo. See ya.